Hi there, and welcome to Western's Fall Preview Day. My name is Luke Stark, and I'm an assistant professor in the Faculty of Information and Media Studies. And today I'm going to tell you everything you need to know about AI in 10 minutes. You've probably heard the term AI talked about a lot recently, but you might not have a good sense of what it actually means. AI, or artificial intelligence, is a broad term for when a machine mimics human traits like learning and problem solving. It's a field that was founded in the 1950s in the aftermath of World War II. But the AI we talk about today is in some ways very different from what the founders of the field imagined many decades ago. Today's AI is based on something called machine learning, or the study of and construction of algorithms that can learn from and make predictions on data and solve problems based on those predictions. Now, you might think that someone like Commander Data from Star Trek or other characters from film and TV are where the future of AI is going. AI is a great thing to have in science fiction and fantasy as a plot device, but we're pretty far away from these kind of sophisticated technological beings. These characters are examples of what we would call general AI, or AIs that can meet or exceed the capacities of human beings. But most of today's AI, in fact, all of it, is narrow AI. It's AI models that are just destined for particular tasks. Instead of looking like Commander Data, AI actually looks more like this: a hard drive and a lot of statistics. Sophisticated statistical models that break down big data sets and find patterns in them to make predictions. Having a little bit of a sense of the history of computing helps focus us on AI and where it's come from. So a computer, as we understand it today, is a digital device that can perform calculations, store and retrieve information in coded form, and execute sequences of operations. Electronic computers were developed in the late 1930s and early 1940s, often under the auspices of World War II defense projects, both in Canada, the United States, and Great Britain. But before these electronic computers, the term computer was once a title for a skilled statistician, often a woman. These human computers did sums longhand and were instrumental to both the war effort and to the development of electronic computers. Women were often at the forefront of programming, operating, and researching computers in the 1950s and 60s. Here's an early computer, and as you can see, it's a lot bigger than the smartphone you keep in your pocket. It's also much less powerful. These computers had to be hand-programmed and took a lot of skill to operate. Among the skilled operators, programmers, and technicians of early computers were many women, and especially many Black women. These hidden figures are often not given their due in the histories of computing and are a focus of much contemporary work in the history of these technologies. So at around the same time as these wartime computers were being developed, the first AI experiments and papers were being published as well. This is a design for the McCulloch-Pitts artificial neuron, one of the first research papers to theorize, though not actually develop, the ability to analogize human brains with artificial electrical synapses. In other words, early AI thinkers hoped that the brain, with its neurons firing, was a lot like a computer sending ones and zeros of electrical data around. Early AI pioneers were excited about the potential for these new technologies. One of the most famous, the British mathematician Alan Turing, pointed out that he didn't see any reason why AIs couldn't do things eventually like write poetry or interact with humans in a natural way. Obviously, these hopes for AI haven't come to pass, but this desire to create an AI that can mimic a human's abilities and pass as human continues to be both a major theme of science fiction and also a major motivator for many people in the field. So getting back to those statistics. So today's AI models start with a lot of data. One of the reasons why machine learning has become so powerful and popular in the last few years is because we're all creating data all the time about the world around us and our actions in it. generating data through our use of smartphones and from digital sensors all over the place. Using that data, AI practitioners will often train a statistical model, which will look for the patterns in that data and find correlations between different features. Then they'll take that model and apply it to some other set of data that is roughly similar to that first set. It's called applying and testing data to make sure that the predictions of the AI actually work. Through an iterative process of improvement, in theory, for some tasks, this means a high degree of accuracy on predicting. However, it's really important to remember the limitations of these machine learning AI systems. They're very good at describing and finding patterns in data, but they've hit what Melanie Mitchell calls the barrier of meaning. This means that they can detect patterns, but they have no intrinsic understanding of what those patterns mean or how they relate to the real world. These AI systems, require human interpretation and engagement. And worse, they're also often susceptible to bias and discrimination. Let's think about for a minute why that would be. So if an AI system is looking at data from the real world, it's picking up all the kind of inequalities and biases that already exist in lots of realms, like employment, education, healthcare, or criminal justice. But instead of doing anything to change those injustices or inequalities, AI systems just replicate them in the data and the models they create, meaning that those predictions get set as a baseline against which future developments are measured. In that way, AI systems don't just discover or reinforce inequality, they might actually make that inequality much worse. It's also important to remember how many humans are actually working in these so-called AI systems. People all over the world are doing work at their computer screens to facilitate the parts of the systems that these pattern predictions just can't do. It's these hidden laborers that are responsible for the kind of apps that you use every day, like Uber or DoorDash. So because of the big impact these ML systems are having on business, healthcare, and lots of other fields, countries around the world, including Canada, are developing both high-level ethical principles and more detailed regulatory frameworks to keep AI in check. This should also include figuring out times when AI systems shouldn't be used at all because of those problems around bias and discrimination I already mentioned. I'm going to leave you with a quick thought connecting AI to the broader situation around digital technologies and our social life. Because these AI models are so common and so widespread in many sectors, it's important to note that digital technology is now at the center of most social conversations, whether those involve democracy, human rights, or the environment. So I hope that if you want to learn more about how AI is affecting these various big conversations and what you can do about it, that you'll get in touch. Or even better, that you'll consider coming as a student to the Faculty of Information and Media Studies at Western. Thanks a lot.